We are continuing part 2 on slide 7. Figure 10.3 demonstrates an example of profit maximization. In the top right corner, you have a cost function. Your cost of production is given by C is equal to 50 plus Q squared. That represents a fixed cost, and this represents your variable cost. And then you're also given your demand curve. P is equal to 40 minus Q, and this is also your average revenue. Now, if you wanted to get your marginal cost from this function, you would get your first derivative from this. So marginal cost would simply be 2Q. And from your demand function, you can get your total revenue function. And to get total revenue, it is PQ. Here you have your price, which is also your average revenue. So if you take this function and you multiply it by Q, you would get 40Q minus Q squared, and then that would be your total revenue function. So in order to get marginal revenue, that would just be the first order derivative of that new function, and that would just be 40 minus 2Q. And of course, to determine the profit maximizing level of output, you would set your MR equal to MC. And although the calculations are not shown here, you should be able to show that where marginal revenue equals marginal cost, that is where your level of output is 10. And if you substitute that 10 into your demand function, you can determine the price, which would be equal to 30. So using algebra, you can solve this, and everything that I just spoke through now is your first year microeconomics. But now graphically, we are going to speak through it, and you should be able to both solve graphically and algebraically. So in the first part of this figure, the following curves are presented. You have your revenue curve or your total revenue. So you would have to derive that from this demand function that is given. Then you've got your cost curve, which is plotted based on this cost of production. And your profit function would be derived algebraically by saying your total revenue minus your total cost, and that would yield a function that you could use to plot your profit. Although we don't have it here, you could do that. So now, if you have a look at this figure, right, it should look similar to what you saw in chapter 8, figure 8.1. The difference here is we have an example applied to it. So now you saw that this cost function has a fixed cost of 50. So if you look at your cost function over here, where it has that fixed cost of 50, for low levels of output, you can see that your cost function in fact lies above your revenue function. Revenue is a function of output. So when output is 0, your total revenue is going to be 0. So in this region Y, while your cost lies above your revenue, you will find that for profit, you'll have negative values for profit. But at the region where you see your revenue lying above your cost, you'll begin to see profit is positive, and it increases as the gap between revenue and cost begins to widen up to the point where this vertical distance between your revenue and your cost curve is at a maximum. That vertical distance, you can see at this point over here, profit is at a maximum. Now, if you look at the output at that point, of course, both algebraically and graphically, we can see that this is the output that maximizes profit. But if you have a look at your revenue curve, if you draw a line tangent to the curve at that point, so this line touches the curve at a point, and if you draw a line tangent to your cost curve at that point, note that the slope of this line is equal to the slope of this line, because these two lines are parallel to each other, so the slopes are the same. And the slopes of this tangent is your marginal revenue, and that is your marginal cost. So marginal revenue equals marginal cost. We can determine the level of output that maximizes profit. In the second part of the figure, part B, we have our marginal revenue and cost curves, as well as our average revenue and average cost curve. So those are our average revenue and average cost. And here's our marginal cost and marginal revenue curves. And this still flows from this example. So you can again see that where marginal cost equals marginal revenue, that is where those two curves intersect, the profit maximizing level of output is 10. It corresponds to that value over there. And if you need to determine the price, remember we are going to trace it up to our average revenue, which is our demand curve. And the price for that level of output is P equal to 30. Now, if we also compare the difference between our average revenue, which is P equal to 30, and our average cost at this level of output over here, there's our average cost, it is 15. We have a difference between average revenue per unit and average cost per unit of 15, 30 minus 15, and that represents your profit per unit of output. So if you want to work out your total profit, you would take this 15 multiplied by your output, your total output that is produced, which is 10. So 15 times 10 is going to give you 150. That distance there is 10. This distance here is 15. 10 times 15 is 150, and the shaded area represents that profit. Coincidentally, see, it matches this value over here. The maximizing profit is 150 when the output is 10. We now move on to shifts in demand. Note that in your textbook, you would skip over the section, the rule of thumb of pricing, and then also the example 10.1. Those are sections that are excluded for second year micro. So let's move on to shifts in demand. Now, in a competitive market, remember, you will recall that there is a supply curve, right, given by the upward sloping portion of your marginal cost curve. However, in a monopolistic market, there is no supply curve. So, in other words, there is no one-to-one relationship between price and the quantity produced. Now, why is that? So, the reason for this is that the monopolist output decision, it depends not only on the marginal cost, but also on the shape of the demand curve. And we're going to see this in the subsequent slide. So as a result, if there are shifts in the demand, it won't trace out the series of prices and quantities that would correspond to a competitive supply curve. So we're going to see now where there are shifts in demand for the monopolist market, it could result in changes in price with no change in output, or there could be changes in output with no change in price, or you could have changes in both output and price. Right, so let's have a look. So in figure 10.4, it shows the shifts in the demand curve. So there are two parts to this figure. The initial demand curve and marginal revenue curve in both of these figures, part A and part B, has the subscript 1. So this demand curve D1, and then it has a corresponding marginal revenue MR1. So that is the initial demand and marginal revenue curves. So the price and quantity where your marginal revenue curve 1 and marginal cost intersect in both parts is going to be given by output Q1 and price P1. So there's your marginal cost curve, and this is the initial marginal revenue curve. So at that point where they intersect, the output is Q1 and the price, if we trace it up to your initial demand curve, D1, is going to be P1. And the same condition is going to hold for this figure over here. So let's just focus on part A. So see what happens when your demand curve shifts downward and it rotates out, becomes flatter. So D2 is now your next demand curve, and it has a corresponding marginal revenue curve MR2. So this is representing what would happen if there's a shift in the demand curve. Now if we see where marginal revenue 2 intersects your marginal cost curve, that is at this point over here, the output is going to be Q2, which is equal to Q1. However, if we trace this point up to your new demand curve after the shift, that's D2, you can see the price is now lower at P2. If we have a look at what happens in part B, with the new demand curve, that curve has now shifted upward and also rotated out, and it has its corresponding marginal revenue curve MR2. So if we see where marginal revenue 2 and the marginal cost curve intersect, that is at this point over here. And if we trace it up to see what the price would be for this level of output on the new demand curve D2, we can see that the price in this scenario has remained the same. However, the output has increased from Q1 to Q2, where we had the shift in demand. So if you were to draw a comparison between what would typically happen under a competitive industry, competitive market, versus what you've seen here under monopoly, you will realize that under a perfectly competitive market, the industry supplies a specific quantity at every price. But this does not necessarily have to hold for a monopoly. You could have scenarios like this where there are shifts in the demand curve, and it could result in the same output but different prices, or you could have different outputs but the same price, or there could be a change in both output and price. We are going to conclude here, and then in part 3 we will continue on slide 10.